All right, so our first kind of notation for electron configuration is called orbital notation. And this is when we actually draw the orbital, right? So hydrogen is in the first shell. It's the first element in the first shell of our periodic table, first row, first energy level, however you want to say that. And so it only has one electron, and that first energy level only has one sublevel, and that one sublevel has one orientation. So I have this 1s orbital to fill here with electrons, and I only have one electron to go in it. So hydrogen's pretty simple, pretty easy. Helium's also simple because it's also in the first energy level, so there's only the 1s orbital to fill, and helium has 2 electrons, you just put 2 in there. Lithium is in my next row on my periodic table, and row 2 is my second energy level, and according to Aufbau principle, right after 1s I go to 2s. So that's where lithium is, that's what I'm trying to do. So I go 1s, I have a 1s that's full, because it has those 2 electrons that helium had, it just has one more. And that one more goes into, the 2s orbital that would come next. So then I put an electron in like that. So pretty simple to start. Carbon, though, is in the p block over here in the second energy level. And after 2s, keep having to go back and forth, is 2p. So when I'm taking care of carbon here, I have a 1s to fill, I have a 2s to fill, and then I'm into p, so I have to draw 3 orbitals for p. So that's what you're going to have to do for p sublevels. D sublevels get 5, F sublevels get 7 orbitals. And we talked about those numbers in our quantum number notes. So this is 2p that I'm labeling here, but carbon only has 2 more electrons than, say, beryllium, that's this 2s that's full. So I need 2 more electrons. Again, I follow Hund's rule, so those 2 electrons are separated. But this is carbon. Carbon has 6 electrons total, however you want to look at it. But really, I don't count electrons very often, or at least the only electrons I count are in that last sublevel. Like I told you, carbon's over here in the p block, but it's also in the second column of the p block, which is how I know 2 electrons should go into p sublevels, right, into those orbitals. So I have 2 electrons here, whereas oxygen is near carbon, it's 2 more electrons, but oxygen is the 4th element in this p block as I count my way over through these columns. So there's going to be 4 electrons in that last sublevel. So again, it's going to look a lot like carbon to start. So whether I had carbon next to it or not, I'd know that I'd go 1s and fill it, and then I'd go 2s and fill it as well. But then my 2p, again, there should be 4 electrons, so I go 1, 2, 3, 4. As long as it is a small element, I can tell that oxygen here, I can count those electrons. I know that it has 8. I can count those arrows. But the bigger it gets, the harder it is to do that. And you don't really want to do that anymore. So phosphorus, I look for it on my periodic table. It's in the next row, also in the p block. So that would be my 3p sublevel. So I look at Aufbau principle, and I know that I have to go all the way to 3p. So I'm going to go 1s, 2s, 2p, 3s, 3p, right? And I don't really need to pay attention to much of anything other than 1s holds 2 electrons, 2s holds 2 electrons, 2p in this case obviously is full because I'm way beyond that. And then I go 3s that has 2 electrons, and then I worry about that last sublevel. 3p is where phosphorus was. So again, if I go check on phosphorus one more time, it's the 3rd element into the p block, so I know I need 3 more electrons. And again, I haven't been counting any electrons this whole time. I've just been filling sublevels, filling orbitals. But if I do count now, I have 3 electrons plus 2 more, plus 6 more, plus 2, right? that should be 10, 12, 15. And phosphorus is number 15, so we're good to go. So I can check myself when I'm done, but I don't really have to know how many electrons I've done already. It should take care of itself, because you can't end up with the wrong number if you had the correct number of orbitals in each sublevel and you filled everything. So potassium is going to be one step further. Potassium happens to be in S again over here, and it's in 4S. So I can go ahead and start with 1S, excuse me, and work my way all the way up to 4S. So basically I need all the same things phosphorus had. I use Aufbau principle and just work in order. 2P should be full. My bad, I shouldn't do that. I'm supposed to put 3 up and then 3 down, just to practice my Hund's rule portion of the rules. Always put 1 in each p sublevel or p orbital before you put 2 in any. Even if I know this 3p is going to be full, doesn't take me any longer to do it this way. It's better practice. But after 3p is 4s, excuse me, and I just need 1 more electron there because potassium again is in the first column. So I should have enough electrons. I can count them to check, but I'm pretty sure this is right. That's how you do orbital notation.